Yeah, Florida. All right, so a week or so ago, we were discussing our normal distributions, and we were looking at what's called the empirical rule. So the empirical rule is a generalization, and really it's an estimation for probability and percentages. So the mean being in the middle of your normal curve. And then if you go out one deviation in either direction from the mean, this is symmetrical, this curve. So these are broken up into little chunks of probability and percentages. So 34% on each side, one deviation out. And then if you go 2 deviations out and 3 deviations out, those little chunks change. So remember, we did make one tiny adjustment, and you will eventually get a formula sheet on this to use on any summatives that we're going to give you. Okay, pen, any day now. It was working today. Just did a whole tutoring thing. Okay, here we go. There's one little adjustment we made, which was the 2.35% is from this second deviation out to there's a little mark at 3 deviations. So, did anyone write this down? It's a teeny tiny percentage. Remember, if there's symmetrical tails, this is 0.15%. And the reason for that is because if you go 2 deviations out, this mark to this mark, on your, on your reference sheet, this is 95% of the data, right? From here to here. So existing outside of your tails would be another 5% of the data. Well, what happens when you take that 5% and you cut it in half? You get 2.5%. So what they did is they took the 2.5% and they broke it up into the 2.35 followed by the 0.15. So that third deviation tail, teeny, 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 tiny. And I don't think it's really written well on your formula sheet that way. So you have to kind of remember that 2 deviations is, that little chunk there is 2.35, between 2 and 3. All right. Let's take a look at, where are we at? Where'd my tree problem go? No, this one. Okay. So we already did this question using the standard curve, using the empirical rule. Yep, always looking good, those empirical rule curves that I'm drawing. So the mean was in the middle, which is 120. And I know we already did this one. But it said there's a standard deviation of 16 inches. So as you move out from the mean, you're going to travel 16 inches in each direction, which we'll talk about percentages in a second. So 16 inches below 120 was 104, and then if you go above 120, that was 136. So that's 1 deviation out. And someone just remind me, what percent is between here and here if I go 1 deviation out in each direction? 68%, yeah. And that's just from the empirical rule. Now, I'm not going to answer this tree question for a moment. I want to go explore with my calculator, and I want to show you what your calculator can do for you. Your calculator can find the probability that you are between this, and much more accurately than the empirical rule is. Now, the empirical rule is it's a generalization, and it only works when you're like whole number of deviations out. Like if you're 1.2 deviations out, that's not really going to help you to have this empirical rule as far as estimation. So we're going to talk about standardizing our data in a minute, but real quick on your calculator. There we go. Every time I do this, I go to the wrong menu. Okay, so go to what's called the distribution menu, which makes sense now that I think about it. It's the normal distribution. And you have 2 options at the top here, which refers to the normal curve. So there's normal PDF and normal CDF. Normal PDF is going to find a single probability at a certain point, and that's not what we're going to be doing today. So you're going to be using normal CDF, which is an accumulation. It's a cumulative data between this point, and that's what we're going to be looking at today. So choose normal CDF. And I'm trying to remember, some of you are using the older calculators. I don't think your screen looks like this. So for the older calculators, you're going to type what we're typing in the exact same order by putting commas in between your numbers. So the first thing you guys have to type is your lower bound. So for that number, I just made up that question. Like, it didn't ask between 1 deviation out. But it was between, help me out guys, was it 104 and 104 to 136. Let's say for some reason they wanted us to find, the percentage between 104 and 136. So on my calculator, the lower bound was 104. Just overtype if there's already something there. And the upper bound was 136. Remember that little Greek symbol is the mean. The mean on the tree problem was 120. So my older calculators, you're typing 104, comma 136, comma 120, comma standard deviation for the tree problem was 16. And then if you choose paste, it's going to paste it into the formula, which is this is what the older calculators, we had to remember how the order went. It was really quite a pain in the tushy. So this newer calculator doesn't make you do that anymore. Hit enter. And we just got approximately 68%. Now this answer is way more accurate. That's the true measurement. The empirical rule is simply an estimation, but it's pretty close, 68% versus 68.27%. So now that you're like, oh, I can use my calculator to do all these? Yes. Yes, you can. Until you go to stats class, and then you can no longer use your calculator to do all of them. And I will tell you, in college, you have some very old school professors who very much like the old way, and they think your calculators are not to be used very often. So there are questions that will come up in a stats class, either in high school or in college, where they're a little backwards. Like maybe one of the variable component is within the formula itself, so you won't be able to use your calculator, and you have to solve the formula. So we'll talk about that a little bit today. Hello. Thank you. 9:20. All right, so let's take a look at the next part of our lesson. This is what it looks like to standardize and find what's called a z-score. So a z-score was most important to like my generation when my teachers and professors would make us look up things in the back of the textbook. So the data itself would be standardized using this formula. A z-score is going to calculate and assume that your mean is at 0 and your standard deviation is always a 1. What's really cool about standardizing your data is then you can compare two sets of data that really have no numerical commonalities whatsoever, but you can look at their data spread like one on top of the other because you've normalized the data and you standardized it. So finding a z-score is something I'm going to need you to be able to do, just because I feel like I can't send you on in Stats Life without knowing what a z-score is. This is how you find it. You take the variable measurement, you subtract to the current mean of the data set, and you divide by the standard deviation. So it's a very simple formula. Let's take a look at it. They want me to find the z-score of, so remember the formula's right here. So 65 minus the mean, 50, and then you're going to divide it by the standard deviation of 10. So I should totally be able to do that in my head. Is that 1.5? Okay. You see the word should showed up there? I should be able to do this all in my head. Some days not. So number 3, be careful here this time. And this is kind of how they get you. If you don't know the formulas, then they ask you something weird like this. This time they give you the z-score. So it's negative 0.4 is actually the z. They don't tell you the x. So x minus the mean of 40 over the standard deviation of 5. So for most kids, they look at this and they view it like an equation or a proportion. So, multiply by 5 on both sides. Is that negative 2? Did I do it right? So far? Are you getting 38? Or is it just me? Yes? Okay, good. Told you, my brain is half sand right now. A lot of sand. I even bought the Surfer Girl Beach Wave shampoo for my daughter and me, and we had really glorious Surfer Girl hair for a week. It was wonderful. We just came back to Florida internet. All right. So let's take a look on the back of this worksheet, and let's see how they're going to use these scores. And really, I'm going to be honest, what we're going to do is we're not going to use these scores, because when we have our calculator, if you want your calculator to calculate things for you, you don't have to standardize your data. But there is a significant importance in our lives for z-scores when we are comparing two different sets of data. Because if one set of data has a different mean and standard deviation than another, it's really hard to look at them and decide like which one is a better fit or which one has more spread out data. Let's see here. Highlight this part in your notes, please, guys. If you are looking at the standard normal distribution, you're going to use z-scores, And your mean is always 0, and your standard deviation is always 1. So whenever you're referring to standardized data, that's what you have to work with. Now, the benefit to using standardized data on the older calculators is your calculator would always assume that your data was standard. So you didn't even have to plug in like mean and standard deviation on the older calculators. So for someone who had to remember how to type things all the time, that was a big benefit. But now with our newer calculators where it just explicitly asks for them, that's not really a benefit anymore. So you'll find as you progress through your stats life in a stats class, you're probably going to use the standard normal curves, the standard distributions less and less, unless you are told you have to. Or if you have a teacher who requires you to. All right, let's talk about z-scores, guys. So this is that same empirical rule, except now they're just, instead of calling them 1 standard deviation and 2 standard deviations, they're just saying +1, +2, +3 because the deviation is 1. And the mean is in the middle, but those percentages are always the same. Now, here's what we had to do back in the day, and this was a total pain. So if your teacher wanted you to find the percent or the probability for your data, you would first calculate the z-score. So like, let's say I did some calculations. I found the z-score to be 1.42 deviations. Now 1.42 is not from my empirical rule. It's in between 1 and 2 deviations. So I'd have to go back to the chart in the back of the book and I'd have to look up 1.4 and then followed over to 2. And then I'd pull up this little percentage off of the chart. And then you'd have to remember that that percentage reads all the measurements to the left of that point on the curve. So if for some reason your teacher really wanted the probability of being greater than this z-score, then you'd have to take 100% minus 0.9222, which isn't that difficult to do, but it's just like one more step in math and it's kind of a pain in the tush. So then it got really crazy when your teacher wanted something like between 1.42 and, I'm just making this up, like let's call it negative 0.3. So then what you'd have to do in your book is you'd look up this negative 0.3 deviations and you'd find this percentage. And then you'd also look up, which we already did, but this guy, and it would tell you this percentage. But guys, answer this for me. How would you find the number between these two? You'd have to subtract them. So it was a hoot. Can you tell? It was a good time. Mr. Dredge loves these, doesn't he? He does a ton of these, I think, yes. He was my stats teacher back in the day too, so I remember. He just, big fan. And then they eventually teach you how to do it on the calculator, and then you feel like, why? Well, there's a reason. You do have to know how to do these by hand, and I think on your AP testing, they definitely still require them to do things by hand. So it's not like the calculator's the end-all be-all to all these questions. For PreCalc, because we have a lot to get through before your SAT test, and we just need to move on in life, I got no problem with you using your calculator. So let's talk about this. On the normal PDF, we are not going to be doing the normal PDF because that's just a single data value. We're going to be using the normal CDF. And this is the order. If you have an older calculator, you're going to want to jot that down. Okay, that's the order in which you're going to type everything. If you're using a newer calculator, you don't have to remember anything, which is kind of fabulous. It's going to ask you exactly what the things are. So let's take a look at this question here. Is this one on your? No. Let's just move. Oh, is that the one that is on there? This question is on there. There we go. Okay, we have 20 airline trips. Oh, this would have been perfect before break. Okay, so 20 airline trips. An employee had an average layover of 82 minutes with a standard deviation of 7.5 minutes. So that looks like very important information, right? 82 minutes is the mean. And then 7.5 is the standard deviation. Find the number. Now be careful. At the end of this question, they want the number of layovers that were less than 75 minutes. So if I want to think about using that empirical rule, we're going to fall into a bit of a rut, I think. Because if I pretend that it is going to use the empirical rule and the mean is 82, 75 minutes. All right, I'm going to need some calculator help. 82 minus 7.5. Go one deviation down from that. Where are we at? 74.5. Okay. And then if I go another deviation down, yeah, I'm still needing help. So 67. Okay. So it's not as an integer value of a deviation down. So 7.5 minutes sorry, 75 minutes would have been right here. So it's close to 1 deviation down, but it's not exactly. So I wouldn't be able to use the empirical rule. So what they would have made you do back in the day in a stats class, and sometimes still today, is they would have you standardize this data by finding a z-score. So 75 is the data point they're interested in. So 75 minus the mean divided by 7.5. And they get a z-score of negative 0.93. So without using a calculator, what you would have to do then is you'd have to go to the back of the book and you'd have to look up what do you get when you have a z-score of negative 0.93, and that would be measuring from this point all the way down the curve, which is what they want, right? Less than 75 minutes. So they would get a percentage, which is roughly 0.176, so 17.6%. I'm just stealing off the calculator work that's already there, but they would have looked that up in the back of the book, and then they would have multiplied it by 20. Is it 20 airline trips? So the back of the book looking up on the chart is really tedious and very annoying. We're not going to do that. What we're going to do is 2 problems on our calculator. I'm going to do the problem with you when we normalized it, or standardized it, excuse me, and then I'm going to do the same problem again without standardization, and you're going to see that they're actually the same thing. So you can go back to the distribution menu, and you can pull up normal CDF. The other thing you guys can do is remember your calculators will bring up previous data entries if you just start hitting enter or go back in your history. So you can just pull up your old one and adjust it if you'd like. But lower bound. Now guys, lower bound just means like all the way to the left of the curve, but remember this curve doesn't actually stop. So your stats teachers usually tell you to just put something really significantly way to the left, even though it doesn't make any sense whatsoever. So like, do you guys do a certain number in stats? Okay, so like, I just go negative 99999, because I'm pretty sure that's way far to the left. Now it doesn't make any sense, right? Like, you're not going to go to negative whatever 999,000, but it's something way to the left. And then the upper bound was they wanted us to stop at, let's do the z-score one. What was the z-score when they calculated it? Negative 0.93? Okay, so that's what I'm going to do for my upper bound. Now on my older calculators, you actually don't, I think you don't have to type mean and standard deviation because you're looking at standardized data. We have to. So I have to pull up a 0 for mean and 1 for standard deviation because I've standardized my data. Paste it into the formula. And look at that, we get 0.176. So 17.6%. Can we redo that problem without standardizing the data real quick? So pull up that distribution again. So what if I never took the time to standardize my data? What if I just kept the mean and deviation the way they were? So the lower bound can still be negative 99999, that's fine. But then what was that upper bound? Where did they want you to stop? It was like less than 75, was that the number? Okay, so your upper bound this time was 75. From the original data, the mean was 82. Okay. And the standard deviation was 7.5. So this is our true data that we did not standardize. Back into the formula, and you get that. What's more accurate? The second one we got is more accurate. Tell me why it's a little off from this one. Yeah, that 0.93, we had to round to get that, right? That's a truncated decimal. So that negative 0.93 z-score was actually negative 0.9. I don't even know what it was because I didn't actually find it. So when you start standardizing your data, you do lose a little bit of accuracy because of truncation. So then your question to yourself should be, well, which one should I do? And my answer is the easier one, the one where you didn't standardize it. So the only reason I would bother standardizing my data and getting a z-score would be if my teacher flat out says, get a z-score. Or if I was trying to compare 2 data sets and they didn't have like comparable means and standard deviations and I wanted to look at them on a standardized normal curve, okay? So for our pre-calc class, I'll probably flat out say find a z-score and then like be done with it. And then I'll ask you other questions where like you have to find the probability between here and here. So it's up to you how you find that probability. let's practice this real quick, guys. At a restaurant, the average time is this, so there's your mean. And then a standard deviation of 1.2, there's your standard deviation. Out of 100 customers, now they want how many, so at the end of this question I'm going to have to multiply it by 100, are within 14 minutes of ordering. So what that means for us is 14 minutes or less, right? So if you wanted to draw this out, and I do encourage you guys to draw this out, even though they're kind of a pain to draw. If I put 12.5 in the middle, I'm not going to standardize it this time. 14 minutes would be like, I don't know, up here somewhere. So I want to know this probability. 14 minutes or less. So now we're going to go to our calculator. Oops. I'm going to go, you guys know how to do second entry like this? Oh, man. Can we just do this? That's what I do. Okay. You go up to the memory and you can go back and adjust it. But now that I realize I'm doing a totally different problem, that was stupid because now I got to retype everything and it overtypes. So go to distribution. Make sure you're picking normal CDF. What would be an appropriate lower bound if I want to go all the way to the end of the curve, guys? Yeah, something really far. And I know it doesn't make any sense to say negative 999,000 minutes, but like whatever. The upper bound. It was within 14 minutes. Don't get hung up on like, does 14, can I be 14? Just put 14 as your upper bound. The mean was it 12.5? Okay. And the deviation was 1.2? Oh, should hit enter. There we go. So it's, 89.4%. But remember it was 100 customers or 100 meals or something. So when it said how many, now I have to take that percentage and multiply it by the end, the 100, and we're going to get about 89. Customers. Okay, there we go. I should have wrote that here. There we go. So we'll do more of those later, guys. It's not bad. And you see on that one, we didn't standardize the data and it didn't affect our outcome any. So the only reason I would go find a z-score, like I said, is if my teacher explicitly says, find a z-score. Or if I'm trying to compare two data sets. And standardizing them will make that much easier for us. All right. Can you flip to the next page of notes? I believe there's something coming up that I want to talk about. All right, something else on my calculator. There we go. So it is worksheet 13, I believe, for you guys. So what if the opposite happens? So what if I want to know like what z-scores and values are associated with that? So we're going to be using what's called inverse norm on our calculator. And the inverse norm is going to only refer back to standardized data. So we have to keep that in mind. So when I'm using inverse norm, they're going to give me z-scores. This is why it's important for you guys to have knowledge of z-scores. What if I want to know the middle 20% of the data or the outside 1% of the data? So that's important in stats because if they have a certain range of values that's acceptable, they want to know like what are we looking at between what two values? Or if they are looking at the extreme grades on an SAT test, like who are the upper and lower 1%ers? Where's that cutoff begin? I talked to some of you about how they score your SAT tests and the scores are normed. This is kind of dipping your toes into that idea. So they take everyone's scores and they norm the data. It's a very complicated process actually. And if they realize when they norm the data that maybe this was just a really hard test and that does affect how they score it. So they can't just tell you like, oh, take your SAT test, and if you get 37 questions right, you have this score. They can't actually tell you that yet. Okay, so it's hard to tell you how to score an SAT test. That's why I always kind of generalize it for my kids, and I say, like, get 65% of the questions right, and you'll have this score. And it's a generalization, okay, because they haven't normed the data yet. All right, on our calculator. This question here said, between what two z-values is associated with the middle 50% of the data? So, what happens on your calculator is they typed inverse norm. Go back to that, I think it's that same menu. I need to stop writing on my calculator. Dumb. And number 3 right there is inverse norm. Choose that. Okay. So on the newer ones, it's going to flat out say like area. Okay. So what did they do? They did 0.25? Yeah. So they did 0.25. I think they still do decimals on these newer ones. Because of this, it's standardized, this data, so we're going to leave it that way because they did ask for z-scores. So your mean is always 0 and your standard deviation is 1. On my older calculators, it doesn't really give you any options. You're just going to do inverse norm of that. So paste into the formula, and it's giving you a z-score. Okay. Now, why did we do the 0.25? Where did that come from? Look at your curve, guys. The middle 50% of the data means that there is 50% of your data on the outside. Yes? What? Oh, it has tail. Did I not have that? Oh, man. You got something fancy. Oh, that's exciting. Okay, so some of you had asked about right tail. Okay, so mine, because it didn't ask me, did it? Oh, man. You have the option to do right tail, center, or left tail. That's even better. Oh my gosh. Well, here's the thing. If you were doing what we were doing, my calculator defaults to, let's see, the positive tail. So the right tail, well, apparently. So that's mine. Oh man. Center. What happens when you choose center? Does it give you lower upper? Okay. Can you choose center and call it 50% and tell me what you get? Yes, yes. Okay, great. Ooh, that's so exciting. Okay, mine doesn't do that, and I feel really, like, sad now. Oh, I wonder if I have to upgrade mine. Okay, how many of you have the tail option? So, like, oh, my yellow ones do it? Yes. Okay, that's very good. So here's what's happening. My calculator, when I use inverse norm, it's going to give me, did it give me negative or positive? It gave me negative. Okay, it gave me the left tail. So it defaults by giving me the lower z-score. But we know that there's symmetry, right? So the lower 25% is a z-score of negative 0.67. If I needed to find this other z-score, well, it's going to be the positive version of that, because remember we had standard data, so 0 was in the middle. But the other way to find that would be to say, okay, self, if this is the lower 25%, there's middle 50% here. At what point are we here? 25 plus 50 takes you up to 75%, right? So they did inverse norm of 75%. So the inverse norm key on the older calculators, and apparently my emulator as well, is always giving me left tail, left tail, left tail. It's always reading down to the left of the curve. So if I need to know the other z-score, if it's not symmetrical, I'm going to have to figure out how far up the curve we are. People with the tails options, you can choose, let's see, if you went to center and did 50%, you said it gave you both, the positive and negative 0.67? Okay. So that's how I would have done that question on those newer ones. If they want the middle 50%, I would have been like, boom, middle 50%, here you go. Man, technology, man. It's awesome. Let's look at some questions that aren't done for us. Right here. Oh, it's kind of done for us. Whatever. All right. Let's take a look here, guys. So it says the middle 25% of the data. I don't know if this is on your... No, it's not. Do one's on yours. Here we go. The middle is 60% of the data. So I like to kind of draw this out. So the mean is in the middle. Oh, gosh. That's supposed to be the middle. 0, and we have 60% somewhere here to here. I don't really know where the scores are, but I know they're supposed to be symmetrical. And they want the z-scores associated with it. So Guys, talk to me about who's, gosh, that's so not centered. Talk to me about these really beautifully symmetrical tails here, right? So if it's 60% in the middle, that means the rest of it is 40%, but they're supposed to be the same. So if it's a total of 40%, that means you got 20% over here and 20% over here, yes? So on my older calculator, what I'm going to have to do is I'm going to have to do inverse norm and find this z-score. I'm going to use the standardized data, so I don't have to worry about the mean or anything like that. Right, it does go. I think I can just type this, actually. Can someone calculate that z-score for me? Go to the hundreds, maybe. I didn't write it down. What a terrible person. 0.84? Negative 0.84, that makes sense. Okay. So inverse norm, the lower 20% is negative 0.84. And then I'm supposed to also find this z-score here. Take a wild guess what it is. Positive 0.84, yes. But if you weren't convinced of the symmetry of this beautiful curve I drew, maybe. What percentage are we talking from here all the way down? Yes, this is the 0.8. So you could do inverse norm of, 0.8, and then you will say, yes, indeed, it's positive 0.84. So from z-scores of negative 0.84 to positive 0.84, that's where you're going to find the middle 60% of your data. Number 9 asks for the outer 30% of the data. Let's see if I can do a little better here. Nope, can't. All right, so 0 being in the middle. And they want the outer 30%. So think about this, guys. Out here is 30% in total. Can you talk to me about what actually is in each of these beautifully symmetrical tails that I totally didn't draw right? 15% of the data, yeah. And who cares about the middle? Because I don't. So to find the z-score associated with this guy, I'm going to do inverse norm of 0.15. And I didn't write it down, so I need some help. What? I'm sorry? Thank you. And then take a wild guess what this one is. Positive 0.19, I bet, huh? There we go. So clearly I didn't draw that well or to scale or symmetrical, but you know, you get the idea. So inverse norm is going to be utilized when I tell you what percentage, what did I screw up? You didn't get that? Oh, for Pete's sake. I don't know. Did you have the wrong tail? Oh, you don't want center, you want left tail. Because we're doing, yeah, okay, so this time, be careful. This is the outside. So like we said, that's not at all what she said. But it is negative. So this must be positive 1.04. Ah, very good. Ah, so there's a little bit of a drawback to the extra cool technology. Make sure you have the right tails on. If I'm looking at the outside data, in that case, you do want to have a tail, left tail or right tail, depending on which one. For the newer guys with your upper tails and lower tails, or they call them right tail and left tail. Okay, so I think what you would do is if for some reason you wanted the top 15%, you would still do 0.15, but then call it the right tail, and it still will give you that same z-score. The possibilities are endless. Oh man, how much fun would that be? All right, guys, do me a favor. We'll come back to that idea when we need to study for a test, but for now, can you look at that yellow packet? I compiled this yellow packet for you. You're welcome. Thanks. This is really exciting. And we're going to skip around a little bit because we haven't actually got to probability yet. We're going to start probability tomorrow. But you guys do have a little bit of probability under your belt from your Algebra 2 lives. So maybe you already know is, but we'll move on. We'll come back to them, I promise. We are going to get all these questions done. And my seniors have already asked me, do I have to do this? And the answer is yes, you do. Now, here's the problem with the probability and stats and data analysis questions on the SAT test. They are not technically math questions at their heart. What are they really? They're really reading questions. And I wish they'd let you use highlighters on this test. Because the difference between a conjunction versus a different conjunction, like an and versus an or, makes all the difference in the problem. So those of us who are not careful readers get very sad about these questions. Now, some of us are looking at this going, well, I'm not excited to begin with because that is a lot of words, Abruzzo. Yes, but words don't mean hard math. Words just mean you got to read a little. So on this worksheet, if at any point you want a really thorough other explanation, or like if we didn't get to it and you want to look it up, if you go to the College Readiness website and you look up SAT number 7 on the Calc section, this is number 4. So they give you these gory explanations as to why this is the right answer and these are the wrong answers. They're pretty clear. They're just very wordy. Math people like to talk about math, you know. So a market researcher selected 200 people at random from a group of people who indicated that they liked a certain book. The 200 people were shown a movie based on the book and then asked whether they liked or disliked the movie. Of those surveyed, 95% said they disliked the movie. Which of the following inferences can be appropriately drawn? This is one of the trickiest questions on the test, and it is just reading. So is it true, can you infer, that 95% of the people who go to see movies will dislike this movie? That seems like a stretch, doesn't it? Like, it's not what the data was showing at all, actually. Let's keep reading. At least 95% of the people who read books will dislike this movie. C, most people who dislike this book will like the movie. And then D, most people who like this book will dislike the movie. Now, people who sat through SAT tutoring this morning, I gave you a little hint on standardized test taking. If there's two answers that look really similar, but they're complete opposites of each other, one of them's it. So it's either C or D. Spoiler alert. Have you figured it out? It is D. So this is the key to the problem, guys. These 200 people that they randomly were talking to, these were people who liked a book. Like, they read the book. They all liked it. That's what they had in common. That's the population. Only people who liked this book. And then, out of those people, 95% of them didn't enjoy the movie. So that's what happened. Sometimes kids read a little too far into the data. You have to look at who your population is that you were sampling in the first place, okay? All right. Oh, boy. That's lengthy. Oh, gosh. Okay. Percent of... All right. So when I'm a little overwhelmed with text, where do I go in a math problem to kind of ground myself? Go find the question, man. Can you find the question? Like, I don't even want to look at this. This is so much reading. Where's the question at? Yeah, it's at the end. Do you see it? What is the... okay, as a math teacher, SAT tutor... They want the difference between the median percent of residents who earned a bachelor's degree or higher for these 7 states and the median of all 50 states. So at some point in our math, we have to subtract something. That's what it means to find the difference. You'd be surprised how many kids don't ever get to that step because they didn't read very carefully. All right, let's go figure this out. Wah, wah. Who remembers how to find median? Totally. Well, the good news is you do get to use your calculator on this one. So if you had to enter the data, you could do a one variable stat and find the median. Remember, that's one of the markers. I think there's an easier way, though. Median is you're supposed to line them all up and cross them off, highest, lowest, highest, until you get to the middle, right? I know they're not lined up in order, but I think you guys are smart enough to do this. Who's the lowest? That was disparaging. I know you guys are smart enough to do this. There, that's better. Okay, 19.5 is the smallest. Who's the highest? Yeah. Okay, who's the next smallest? Yeah, you. Who's the next highest? Yeah. Lowest? Highest? Boom, middle. All right, what would have happened if I got to the middle and there was 2 middle ones? I would have averaged them. Add them up and divide by 2. Found the middle of the middle. Okay, but good news. The middle of this list is 27.9%. And then if you keep reading, the median for all 50 states was 26.95. And they want you to find the difference. So you're supposed to subtract. And this is where a lot of kids found the median because they did that skim reading stuff that we all love to do. And then they're like, wait a minute, it's 27.9, and that's not anywhere on my list of answers. So read a little more carefully when that happens. I am really shocked they didn't put 27.9 as an answer choice, which obviously would be wrong. But that was nice of them, I guess. What's the difference? 0.95? Okay. Now the good news is that was on your calculator test section. So if you were in a jam, maybe you could have had a little calculator assistance, but it wasn't necessary, right? And do you think it was faster to do it on your calculator? Absolutely not. And those of us who've taken a practice test will tell you you're going to run out of time. Seniors, you going to run out of time? Oh no? Did you get the score you wanted? That's a different question, Abruzzo. We're not talking about me. All right, number 7, back to the next column here. Or not number 7, 37. This is a gridded response question, which I know my seniors know what that means. Everybody else remember what that means? The bubble in ones? Yeah. So you can't actually guess on these. I mean, not effectively at least. What is the mean score of contestants on day 1? Well, what does mean mean? You would add them up and divide by how many, huh? However, guys, this is not as easy as it looks. You don't add these up and divide by 1, 2, 3, 4, 5, 6. You have to add up all their scores. So this says that 2 people scored 5 out of 5. Okay? 2 people scored 5 points. And 3 people scored 4 points. And 4 people scored 3 points, and so on and so on. 6 people scored 2 points, and 2 people scored 1 point. And obviously you don't really have to add in the 0 because it's just going to be 0, but if you want to keep it consistent, you can. Can y'all add that for me? So what you're finding is total number of points that were scored throughout day 1. What is it? 48? Okay, so 48 points scored by how many people? 20 contestants. So the average score was 2.4. Now this was on a calculator test, so you could have entered data into your list. I just don't think that would have been worth your time. All right. And 2.4 is a good way to bubble it in. We're going to come back to 38 later because it's a conditional probability question that we have to discuss tomorrow and maybe Wednesday. But keep this yellow packet handy, guys. These were straight off of some SAT tests, so hey, thanks. Oh, you can keep some of it if you want here. It's all you.